Hi class, we're on section 7.3 today. We're solving equations using quadratic techniques. So quadratics means we have an x squared term. So these are polynomials, which means we have an x cubed, x to the fourth, x to the fifth. Those are our degrees. But we're still going to solve them using quadratic techniques, most oftentimes using factoring. So get ready to factor again. We're never going to get rid of factoring. Factoring is going to be in every math class that you take from now on until you're done with school. So make sure we get good at it. So we see this one, x to the fourth plus 7x cubed plus 12x squared minus 0. What we can do right away is the very first rule for factoring is take out a GCF if you can. So let's take out an x squared, because every term in that trinomial has an x squared term. Now I have x squared plus 7x plus 12. That equals 0. Everyone understand what I did there? I took an x squared out of this term, I took an x squared out of this term, and I took an x squared out of this term. Now I have a trinomial that can be factored. So I still have my x squared out here, but now my trinomial I'm going to form into two different binomials. And that's going to be x times x gives x squared, and then a positive 4 times a positive 3 gives me my 12, and then when I take 3x plus 4x, I get my 7x in the middle. So I have successfully factored it. But we don't stop here, we're solving, okay? So we want to get x all by itself. So all three of these are factors that equal 0. So let's set these equal to 0. X squared equals 0, x plus 4 equals 0, and x plus 3 equals 0. So solving, take the square root of both sides, we get x equals 0. Class, remember that whenever we take the square root, we need to get two answers. It's always plus and minus, although if we take 0, there's no such thing as plus and minus 0. So this means when x equals 0, we're going to get a double root right here. And I need to see that on your next chapter test. There needs to be 4 answers. Our degree is 4. We're going to get 1 from here. We're going to get 1 from here. And then we have to get the other 2 from this. So remember what happens when we get a double root. You'll see the graph in just one moment. We'll quickly solve these. X equals a negative 4 and x equals a negative 3 when you subtract 3 to get on this side and subtract 4 to get on this side. So x equals a negative 4, x equals negative 3. That's where it crosses the x-axis at. So notice right here at a negative 4, here at a negative 3, and then my double root, remember what a double root means. It doesn't pass through my x-axis. It goes down, it touches the x-axis, and then hops back up again. That's what a double root means. It doesn't pass through the x-axis, it just touches it. So that's what you'll always see whenever we get a double root. So those are our 4 answers for this question. And again, the roots, or the zeros, is where it crosses the x-axis. 1, 2, 3, 4. It also satisfies the equation, so you could put those numbers back in here for x, and you're going to get 0 equals 0 if you want to check your work. Why don't you guys pause the video and try number 2 on your own. Alright, after you've tried this one on your own, you've factored out an x cubed first, hopefully. And that way you got an x squared plus 11x plus 24 equals 0. So now we have x cubed times 2 different parentheses. And those parentheses are x times x and 8 and 3. So our roots, x cubed equals 0. X plus 8 equals 0, and x plus 3 equals 0. So now when we cube root both sides, we get x equals 0 again, except this time it's a triple root. You'll see what the triple root looks like when I reveal the graph down below. The other two are x equals a negative 8, and x equals a negative 3 when I subtract 8 and subtract 3. So it crosses at a negative 8. My graph doesn't show this one. Here is 1, 2, 3, 4, 5, 6, 7, 8. So my graph crosses one time here. It crosses another time at a negative 3. And then when there's a triple root, it kind of passes through it in a strange kind of a way. You're always going to see this look when we get to triple roots. So it kind of flattens out as it goes through 0, and then as it hops back up again. So whenever you see a triple root, this is the kind of look that you're going to see on the graph. Alright, let's try the next one. So there's our 5 answers. 3 of them at x equals 0. There's the 4th one. There's the 5th one. So remember, our degree tells us how many answers we should get. Looking at number 3, we should get 5 answers again. So make sure we get 5 answers after we're done with this. You can take out an x cubed again. So then you're left with an x squared minus 196. That equals 0. Whenever you see 2 terms, class, instead of 3 terms, we see 2 terms, and there's a subtraction sign in the middle. You should always think this might be the difference of 2 squares, and try to treat it that way. X cubed times, try to form 2 different binomials again. It's going to be x multiplied by x gives us the x squared. And then is 196 a perfect square? The answer is yes. It's a negative 14 multiplied by a positive 14. So that's going to give us our negative 196. And they're conjugates of each other, which means the middle term is always going to cancel out. So we have 3 factors. Let's set them equal to 0. X cubed equals 0, x minus 14 equals 0, and x plus 14 equals 0. Solving, cube root both sides, and we'd get x equals 0 triple root. Next one, x equals a positive 14, and x equals a negative 14. So if we were to graph this on our calculator, it would pass at negative 14, which is way over here. It would pass at a positive 14, which is way over there. And there's a triple root at 0, which again, you kind of see how it flattens out as it passes through 0 right here. That's what you're always going to see when you get the triple root. So there's our answers. 1, 2, 3, 4, 5. You guys pause the video and try number 4 on your own, please. Alright, you should have factored out a y to the first, and then you get y to the fourth minus 144. That equals 0. Maybe some of you got lost at this point, but others of you might have seen that once again you get 2 terms with a subtraction sign in the middle. It's very possible it's the difference of 2 squares. So we're going to make 2 different parentheses. I know that y squared multiplied by y squared gives me a y to the fourth, and 144 is a perfect square. It's a negative 12 times a positive 12. So I have successfully factored this binomial into 2 other binomials because it's the difference of 2 squares. Now I have 3 factors. Let's set them all equal to 0. So y equals 0 in this one. Y squared minus 12 equals 0. That's this one. And y squared plus 12 equals 0. There's that one. Okay, y equals 0 is one of my 5 answers. Y squared equals a positive 12 when I add 12 to get it to the other side. Square root both sides. I got the square root of 12, which is the same thing as 4 times 3. So y equals plus and minus 2 square root 3. I broke down the square root of 12 to make it 2 square root 3. And whenever you take the square root of a number, you need to have the positive and the negative. So there's 2 more answers. And then my other one, y squared equals a negative 12. Square root both sides. A negative 12 factors down into 4 times 3 times a negative 1. So I get y to equal plus or minus the square root of 4 is 2. The square root of negative 1 is I. And then I have my square root of 3 left underneath the radical. Whew! There's my 5 answers. Y equals 0. Y equals plus and minus 2 square root 3. Y equals plus and minus 2I square root 3. Remember what an imaginary root is? Those are ones that do not cross the x-axis. So I have 3 real roots. One crosses at 0. That's this one. One crosses at 2 times the square root of 3. That's that one. And one crosses at a negative 2 square root of 3. That's that one. These other 2 right here are imaginary. You still need to write them down, but you won't see them on the graph. You guys pause the video. Try number 5 on your own. First, you got to get it to equal 0. So x to the fourth minus 13x squared plus 36 equals 0. Hopefully you did that first. We can take out a GCF on this one. That stinks, but no worries. We could still go x squared multiplied by x squared to give us x to the fourth. Factors of 36 would be, let's see, a negative 9 times a negative 4. That gives us our positive 36, and when we take the inside and the outside terms, we'd get a negative 4x squared minus 9x squared gives us our negative 13x squared. So we're good to go. We've successfully factored it. Don't stop there. Those are 2 factors. Let's equal them to 0. We should get 4 roots with this one. So x squared minus 9 equals 0, and x squared minus 4 equals 0. So we'd get x squared equals 9, x squared equals 4, square root both sides, and we would get x to equal plus and minus 3, and x to equal plus and minus 2. Square root 9 and square root 4 is 3 and 2. So it passes at a negative 3, a negative 2, a positive 2, a positive 3. Those are our solutions for this equation. Those four. Okay, here we go. The last two. Oh, sorry, I'm getting ahead of myself here. Problem number 6. Let's again factor this. So we have x squared and x squared, a negative 4 and a positive 3. That's how we'd factor this one. And now those factors would equal 0. So we would get x squared minus 4 equals 0, and x squared plus 3 equals 0. X squared equals 4, square root both sides, x equals plus and minus 2. Subtract 3, x squared equals a negative 3, so that means x equals square root both sides, plus and minus I square root 3. So you have two imaginary roots and you have two real roots. The two real roots cross at 2 and a negative 2. So right there and right there. Uh-oh. I did this one wrong, didn't I? My apologies. Rats! This should have been the positive 4. Stink! This should have been the negative 3. Because that would still give me my negative 12. And then negative 3 and a positive 4 would give me a positive x squared. Okay, so all this blue stuff is irrelevant. Sorry about that, class. Alright, so now instead we should have gotten x squared equals a negative 4. So when we square up both sides, x equals plus and minus 2i. And then we should have got x squared equals a positive 3, which means x equals plus and minus square root 3. There we are, and that's how we got our roots, the two real roots, to be right here, which those are the square root of 3 and the negative square root of 3. And then our two imaginary ones are 2i and a minus 2i. Okay, the last two that we have in our notes for today is going to be the sum and difference of two cubes. So when you see two terms and one of them is a cubed, you got to think, I wonder if this is the sum or difference of two cubes. This is a positive sign right there, so think the sum of two cubes. This 343, that's the same thing as 7 cubed. So when we talk about our formula, a cubed, a plus b times a squared minus ab plus b squared, a is the cubed root of the first term, which is x, and b is the cubed root of the second term, and that number is 7. So now we're going to factor this. It's always going to be the same. It's a binomial and a trinomial. The binomial has a positive sign in it. The trinomial has a negative and then a positive. So it's going to be a plus b, x plus 7, times a squared, which is x squared, minus ab, so minus 7 times x, which is 7x, plus b squared. 7 squared is 49. So I have successfully factored it, but I can't just stop there. What I now need to do is I need to solve. So each of these are factors which you set equal to 0. So x plus 7 equals 0, and x squared minus 7x plus 49 equals 0. My first answer, subtract 7, x equals a negative 7. That's the easy one, and that's going to be this one right here, a negative 7. The other two are found right here. In class, just to let you know, that can never ever be factored. Whenever we do the sum or difference of cubes, the trinomial can never be factored, so you have to use the quadratic formula with this one. That's how you find the other two roots. So it's a negative b plus or minus the square root of b squared minus 4 times a times c all over 2 times a. 2 times 1 is 2. And now we're going to simplify this to find our other two. Alright, when we simplify this part right here, we get 7 plus or minus the square root of 49, and that turns into a minus 196. This circle part that I just wrote down here is a negative 196 all over 2. So now when we simplify this part of the radical, we get the number a negative 147. So we have 7 plus or minus the square root of a negative 147 all over 2. Now we see if we can reduce our radical at all. So can we break down a negative 147? A negative 147 can be broken down into 49 multiplied by 3 multiplied by a negative 1. So I can take out the square root of 49 to make 7, and I can take out the square root of negative 1 to be I. So it's 7i square root 3. So my answer, 7 plus or minus 7i square root 3 all over 2. X equals that. So my two answers, the first one was a piece of cake to find, x equals negative 7. The other two are more difficult because I had to use the quadratic formula. This one right here. Alright, let's try that one more time. You guys pause the video and try that one on your own. This is the difference of two squares. So our a value is going to be the cube root of the first term, which is 2x. Our b value is the cube root of the second term, which is 3. So it's going to factor down into a binomial and a trinomial. The binomial for the difference of two squares has a subtraction sign in the middle, and the trinomial has two positive signs. So it's a minus b, 2x minus 3, times a squared. 2x times 2x is 4x squared, plus ab, 2x times 3 is 6x, plus b squared, which is 9. Here we go. These two factors equal to 0. So 2x minus 3 equals 0. This is our easy one. X equals 3 halves when we add 3 and divide by 2. There's one of our answers. The other one, 4x squared plus 6x plus 9 equals 0. This one's more difficult to find because we got to use the quadratic formula. It cannot be factored. So it's a negative b plus or minus the square root of b squared minus 4 times a times c all over 2a. 2 times 4 is 8. So we get a negative 6 plus or minus the square root of 36 minus 4 times 4 times 9 minus 144 all over 8. 36 minus 144 is a negative 108. So it's a negative 6 plus or minus the square root of a negative 108. All of that divided by 8. We got to break down our radical if we can. So 108, a negative 108, breaks up into 36 times 3 times a negative 1. So that means it's the same thing as 6i, square root of 36 is 6, square root of negative 1 is I, so 6i square root 3. So we get a negative 6 plus or minus 6i square root 3 all over 8. And finally, we got to reduce all of these can be divided by 2. So it's a negative 3 plus or minus 3i root 3 all over 4. There's our three answers. Two of them found by using the quadratic formula. We should always have x equals here. Sorry about that. X equals a negative 3 plus or minus 3i squared 3 divided by 4. And the other one is x equals 3 halves. Let me know if you have any questions on that when you get to class tomorrow.